Unit number 6, Solving Systems of Equations. Systems of equations is when we have two or more equations working together. In Algebra 1, we solved linear systems with two unknown variables. We solved these systems using three different methods. Graphing, where the intersection is the solution. Substitution, where we solve for one equation for either variable and substitute it into the other equation. And elimination, where we eliminate one variable by adding or subtracting the equations. At this time, we will review substitution, solving one equation for either variable and then substitute it into the other equation. Let's look at an example. Solve the system of equations by substitution. Now, usually set up 4 columns to take care of this. The first column, I choose an equation that looks easy to solve for one of the variables. In this case, the first equation looks like it would be easy to solve for x. So I write down the first equation in the first box. The second box will hold the second equation, or the equation that I did not use. The third column is the first equation again, and the fourth column is my check. Solve the first equation for x. To do this, we add 2y to both sides. This leaves x equals 2y plus 5. Now that I know what x is, I can substitute it for x in the second equation. In the second equation, we need to remember that we are putting whatever we found for x in parentheses. Then we distribute to solve. 4 times 2y is 8y. 4 times 5 is plus 20. Combining like terms, 8y and 3y is 11y. Subtract 20 from both sides to solve for y, and we get 11y is equal to negative 11. So y is equal to negative 1. Now we know what y is, so we can substitute it back into the original equation that we started with to solve for x. X minus 2 times negative 1 equals 5. So x plus 2 equals 5. We still need to solve for x. Subtract 2 from both sides. And x is equal to 3. We write our answer as an ordered pair. Alphabetically, x comes first. Now we need to check our answer into both equations to see if this is true. Substituting 3 in for x and negative 1 in for y. So in the top equation, we want to see if x minus 2y equals to 5. So plugging in 3 for x and negative 1 for y. Is this equal to 5? So 3, negative 2 times negative 1 is plus 2, and 5 is equal to 5. Yes, this checks with the first equation. But with any system, we need to check both equations. And this does check. So my answer is 3, negative 1. Another way to solve a system of equations is by elimination. To solve a system by elimination, we look for a letter that we want to get rid of, either the x or the y. and we try to figure out how to eliminate it. By looking at this example, we have 12x and a 3x. If I multiply the bottom number by a -4, I could get rid of the x's. I also have an 8y and a 4y. If I decided to eliminate the y's, I could multiply the bottom by a -2. And that actually looks like the easiest of the two to do. So I'm going to multiply the bottom equation by -2. Now when I multiply the bottom equation by -2, I need to remember to multiply all the way through the whole equation to keep it equal. So rewriting the top equation, 12x plus 8y equals -8. Rewriting the new bottom equation right underneath it, we add the two equations together. The y's will eliminate or cancel. 12 minus 6 is 6x. -8 minus 4 is -12. Divide both sides by 6, and x equals -2. Make a column and plug -2 in for either one of the equations. And it looks easier to plug it into the original second equation. So where I have an x in the second equation, I will replace it with -2 and solve for y. 3 times -2 is -6 plus 4y equals 2. Adding 6 to both sides, 4y equals 8, so y is equal to 2. I have the answer -2, 2. But remember, we must check our answers to make sure that it is correct. By substituting -2 in for x and 2 in for y, we are able to see that the left side does equal the right side, and -8 is equal to -8. But we also need to check it with the second equation. In the second equation, we substitute -2 in for x and 2 in for y to see if the left side is equal to 2, and it does check. Choose an appropriate method and solve. This means that I can choose substitution or elimination. If I chose substitution, I could solve for y and then substitute that answer back in. But this problem is real easily set up for solving by elimination. Notice that if I multiply the top by 3, the y's will cancel. So rewriting the two equations to solve, we now have 18x plus 3y equals -15, and 4x minus 3y equals -7. Draw our line and combine these two equations. 18 plus 4 is 22x. The y's cancel, and -15 and -7 is -22. X is equal to -1. Draw my column bar. Substitute -1 back into one of the original equations. In this case, the easiest one looks like the bottom one. So everywhere I have an x, I will substitute -1 in its spot. We get -4 minus 3y is equal to -7. multiply 4 times negative 1 to get negative 4, minus 3y equals negative 7. Solving for y, we add 4 to both sides. Negative 3y is equal to negative 3. Dividing by negative 3, y is equal to 1. So our answer should be negative 1, comma 1. But of course, we need to check. Substitute our answer back into both the equations. We want to see if the left side is equal to negative 5. And yes, this is a true statement. So far this works, but we also have to check it with the second equation. And that is a true statement. So negative 1, 1 is our answer. And this is a review of solving systems of equations.